Hi guys, welcome to another installment of Vocal Debate Tutor. Today I'm going to take you guys through how to do some performance tuning for Oracle 11G and 12C. Basically, I'm just going to focus on I'm just going to focus on built-in database tuning. But I mean, tuning your tuning your some parameters and basically just it's going to be more of a system tuning that I'll be doing. And then the second tuning that I'll focus on is on SQL tuning. I'm going to tune the actual queries that the scripts that you're writing inside of the Oracle software to the Oracle software. Okay, again, so in terms of doing some database tuning, these are the things that I'll be focused on. I'm going to focus on sizing your database logs for high performance. By database log, I'm referring to your redo logs, and I'm going to tell you just how, if you size your redo logs correctly, how that can make improve the software performance, also just the overall user experience with the Oracle database. And I'm going to focus on the program goal area. I'm going to focus on the parameter, the PGA aggregate target. Basically, and I'm going to just tell you, actually tell you and show you guys how this parameter and what the PGA exactly does inside of the Oracle software. I'm also going to focus on the stat pack utility. I'm going to show you guys how to use it and basically what and how that can how you can use this utility to basically just monitor the performance of the database. I'm also going to focus on SQL tuning advisors. Basically, it's just a it's just a set of advisors that Oracle basically integrate into the software, where basically you can rely on their sort of hints or the information that is telling you to basically attain high performance for your database. And I'm also going to go over basically how to basically just plug database packages into memory, actually just peg them. But I mean, let's say you have a bunch of packages that you execute frequently. Basically, as opposed to just always having to having to just run those packages. If you're a DBA developer, just run those packages from the at the time that you would like to run it. But again, that's not going to lead to optimal performance. So I should advise that if you're going to do that, then you should just have those packages in the memory, so you can just sort of bring them sort of bring them up as you need them more easily. So in terms of sizing your database redo logs, so basically Oracle recommends that you perform a redo log switch every 20 minutes. So an example that I've heard is, let's say you have two redo logs in your configuration, and you have them set up for, let's say, 115 megabytes, and basically and basically, let's say that with 150 megabytes, what they're doing is they have a switch every 10 minutes. So we want 150 megabytes, that is every 10 minutes. That's for each video log. So what you would do then is, again, Oracle recommends that the video log switch occurs every 20 minutes. So what you would do is you would just increase the size of that video log to 150, then increase it to 300, and then so that will move the video log switch time to 20 minutes, which is the Oracle recommended time. So just in terms of sizing your video logs, just be mindful of Oracle recommendation for 20 minutes. For the video log switch. And also, again, this is just basic. A minimum, Oracle requires a minimum of two video log groups inside the Oracle software. Again, the reason why is basically the video logs are written cyclically. So basically, you would have one video log be responsible for the dividing and then for the intake of the data, and then what it would do is it's not going to keep that data into its file. It's going to pass that information onto the other video log. So it's written cyclically, because going back and forth, the video logs are just being filled up and being flushed back out right away. And that's just the way that the video logs work. In terms of basically just performing that video log switch, to do it manually, you can issue the command auto system switch log file. That's the way to execute a video log switch manually. And also, again, what I'm going to do now is I'm just going to assume that the database is in archive log mode, which makes administering video logs much simpler. The reason why is, again, typically what happens is that once the video logs are filled up, they actually, when the data is flushed out of the video logs, they actually go straight into the archive log files. So that's the reason why I say simpler, because basically that the information the information that's being trapped, or that's being captured by the Oracle software, it's definitely going to be you would definitely be able to refer to it later on. If let's say in terms of, let's say you experience a system failure or any system failure, you'll be able to refer to those video log, those archive logs, which basically retain information from the video logs. And then also basically in terms of video logs, basically I'm gonna show you guys how to basically just tune the video log buffer cache. I'm gonna just show you what it is, and then I'm gonna go over how it works. So there are some parameters that you have to be aware of in terms of administering your video log buffer cache. So basically, the first one is a log checkpoint timeout. So basically, what it says is it's the length of time before the buffer the buffer is flushed out, or actually the data in the buffer is flushed out into the online video logs. And this is measured in seconds. So what that means, so again, I just gave you an example of how you would have two video log groups, and also those can be referred to as online video log groups. So how you have those two online video log groups, and then how basically in terms of the buffer cache, what the buffer cache would do is it would take the information that it has, and this is where this parameter comes in, the log checkpoint timeout. So the information comes from the log buffer cache, the video log buffer cache. But the thing is, you can actually you do not have to you can actually administrate over how long that buffer cache takes before it's able to flush out that data. And this is the parameter. This is like what this parameter does. So the default is 1800 seconds. So if you want the video log buffer cache to flush out the data much faster into the online video log groups, then you can just make this sort of like adjust this value to match what you like to see happen. but then again, the default is 1800 seconds. And also, you have the log checkpoint interval. So what it is basically it's the it's actually it's the so it's the it looks at the number of blocks inside of the buffer cache, number of blocks that have failed basically. And what it does is, again, that's also used to determine if the to determine when the redo log buffer cache should be flushed out. So basically, it's gonna say, okay, how many blocks are currently I've already moved into, and then it's just gonna say, okay, we've reached the amount of blocks that the user requests, that the user so like the amount of blocks that the user used during the setup, and then it's gonna flush the data out into the online view log. And you can set this parameter. Again, it's not seconds. It's just the number of blocks, and and specifically it's the number of OS block, operating system blocks. And also in terms of the redo log buffer cache, you also have when you experience a system failure, instance failure, what happens is that the database has to start back up. And basically the way that you can and then again once this happens, you're gonna have a you're definitely gonna have a log switch occur. And basically what's gonna happen is that you're gonna have to basically just set up this parameter, the fast.mttr target. So what it is basically how long the database should take from the time that the failure happened to how long should the database take to start up after the failure occurs. So basically the default is 900 seconds. So that would be how long the database from the time that you experience instance failure to basically all the view logs being applied to the database for the database to stand up again in a consistent state. So that's just you can also set this parameter to really to improve the performance by if you want the database to be started quickly, then you're gonna have that's possible because what you'll be doing, you just be assigning a lower value for this parameter, and that's gonna help the database. That's gonna make the database start up quicker. But then again, it's all about really what you want for your environment. I'm not gonna tell you one way or the other, but just be mindful that this is a tool that you can use to better the performance of your Oracle software after you've experienced an instance failure. So basically, this is what the database looks like internally, right? So basically, what you have is typically you have an application here, a client, and actually, yeah, this is more like what it looks like. So you have an application on a client, like somewhere on the outside. That would be a user like me, for example. So what you do is you just all the information that you're writing is basically it's being it's going to be the way that the information gets to the database is through the server process. So basically that's what I'm saying. That's why I said that this is typically what happens in an Oracle database. But back to my point. So basically what you have here is that you have a database buffer cache. So what happens is that basically if you look inside this database buffer cache, you see that some blocks are clean or empty, and you have some that are dark and gray, and those would be referred to as dirty blocks. So basically, if you look at this database buffer, you would say that it has a lot of dirty blocks, and dirty blocks is actually not not a really not a not it's part of the process, because what happens is that he basically just tells he tells what's known as the database writer that this information needs to be flushed out into the database file. And so basically what will happen is you would as a user, you would write a code, you would go through a set of transactions, like issue set of statements, also called transactions, and then they will be taken into the database buffer cache. And what the database buffer cache would then do is it would the database writer would if the server process can no longer write to the database buffer cache because there are too many dirty blocks, then the database writer process would actually go inside the database buffer to clean up the dirty blocks, and then take that information and place it in the data file. And specifically, it's going to place it in the data file header and the control file header. And then basically, and then again, in terms of the database writer, you would the maximum that you would have for the number of database writer is actually 20 processes, and typically it would be just dbw0 to 19. It doesn't start with 1. And then so from this. Okay, so once this occurs, right, and as I just said, so when you have the control file header and data file header updated, it's actually referred to as a checkpoint. It's a checkpoint process to be exact. The checkpoint process. And then and in terms of the server process and what else it does. Basically, what it also does is, in addition to writing the submitting your transaction data into the buffer cache, he also writes the video log buffer. And as I've just told you, basically the video log buffer then applies that information to the online video logs. And the process in between that actually makes this possible is the log writer process. So the log writer process just takes information from the video log buffer and takes it to the online video logs. And then once you have the information the data inside the online video logs, again this is another view of the video log, and the log writer taking information from the video log into the online video logs. The video log buffer into the log writer taking information from the video log buffer into the online video logs. Basically, these are the online video log groups. So basically, what would happen is that again, as I've told you, you're supposed to have at least 2 online video log groups, because what would happen is one would be the way that the writing takes place inside the online video log is the video log is filled up to the top. And then basically what will happen is that over time this data is gonna be flushed out into this online view log, and then it's gonna be flushed out into the next one. So basically what you have is this information going from 1, 2, 3, 4, 5, 6, and then eventually makes its way to the archive video logs. So that's what I meant when I said, again, it's cyclical. The information is, it's never in just one online video log. It's always being moved around, and ultimately ends up in the archive logs. Again, you can use that to perform, recoveries and restores for your database. And in terms of the program global area, again, this is a parameter that you use to set up the program global area. Actually, before I get to that point, so basically the reason why I went over this setup is basically in terms of doing performance tuning. So just think about it this way. So if you can sort of optimize any part of the She can optimize. Again, I'm gonna focus specifically here on the video log buffer. Yeah, I'm gonna focus on the video log buffer. So basically, again, so you already know what's gonna happen. You already know what's gonna happen with the with the with the the database buffer cache. That, you know, again, the database writer will be responsible for you know, for, you know, taking the dirty blocks into the data file. But what you can do here is you can actually optimize the video log buffer. As I've told you guys, you know, from the previous slide, you have these two parameters: log checkpoint timeout and log checkpoint interval. Basically, you can sort of, you can tell the video log buffer how long before it flushes out the information from the video log buffer, or you can also tell the video log how many blocks it should allow to be filled before basically sending information over to the online video logs. So basically, again, in terms of optimizing, so if you have control over that, you can basically just make this process just go a little bit quicker. And if you do that, then basically, you know, what you're doing is you're essentially improving the performance of your database by doing this, you know, by just optimizing how efficiently you think the video log buffer should run. Again, that's just one of the things that you should consider in terms of you know, optimizing your database. And in terms of as I was saying, in terms of the PGA, it's like the parameter for that for the PGA program is like the PGA get target. Basically, if you look at this picture that I have, so you have a connection of basically into the Oracle, into the host server. So basically, what will happen is that the user process will communicate with the server process, and the server process is actually where the PGA is stored. So think about this, right? So if you have multiple user processes, right, you would have all those user processes communicating with the server processes, and then each server process would have a little bit of PGA attached to them. So this parameter is just what it is. It's just the overall value for all of the PGA. So let's say you have about 2 user processes. Just to make it easy, you have 2 user processes, and basically the user process is connected to a server process, and you have a PGA. So what would happen is that the PGA aggregate target, let's say we set the PGA aggregate target to about 60 megabytes. What would happen is that the 60 megabytes would actually be the value that would be applied for the PGA for user process number 1 and the PGA for user process number 2. So again, based on the activity level, how much memory the PGA is taking up is going to be determined. The amount of activity is going to determine how much memory will be allocated to the server process, the PGA inside the server process. Basically, it's all based on the activity level. But again, this is a parameter that would set the overall value. As I just said, you know, basically inside the program global area exists inside of the server process, and once you said you've set the value for all of the server processes, and then again, this is really important. The default is 0. Actually, you know what? So this is again, when I say default 0, I'm actually assuming that you'll be using on the automatic memory management, which is one of my other bullet point. Basically, what AMM does is it actually it does the memory management for both the PGA and the SGA. So basically, once you set this parameter, you would just allow for the Oracle software to be responsible for you know allocating more memory to one or the other, either to the PGA or the SGA. The measurements, how this value is measurement for this value actually is in megabytes. So in terms of the program global area, so basically what Oracle recommends is you should. So Oracle recommends that the program global area should be 16% of your total physical memory, and that's for an OLTP environment. So again. So let's say, going back to this example, if you have, I'm not really good at math, but so if you have, going back to the example about having 60 megabytes overall, I mean for your PGA, it's actually, that's actually not, that's a good value to give as an example. But let's say you have an open environment, you will need to do some calculation, some, some adding and some subtracting to be able to get to the actually, you know what, yeah, you definitely need to do some math to get to a value for your PGA, both for OLTP and for an OLAP environment. Basically, again, it's 16% for of total physical memory inside of OLTP, and then 40% inside of a data warehouse. And basically, in terms of, so okay, this is okay. You might be wondering, so okay, if this is so crucial, then why does Oracle recommend only such a small amount, right? 16% and 40%. But the truth is, so you do not. The thing is, you do not want to have a PGA that's too large. You want to avoid it at all costs. Basically, what happens is that, so if you look at this diagram, right, this is what's inside of the PGA. You have all these, you have a sort area, hash area, bin merger, all these different work areas, right? And so what would happen is, if you have the server process, if this is inside of the server process, what would happen is that a lot of the operations that are taking place would actually take place inside of these work areas. And basically, if you have so much work, so much of the work, being taken up by the PGA, then what happens is that it's gonna again, if you look at this diagram also, it's gonna take remember, the server process, all the server process is actually doing is it's gonna take your information, the that you submitted, that you committed. It's gonna say, okay, one, I want to send you to the database buffer cache. Two, I'm going to send you a video log buffer. But if you make it difficult on the server process by expanding the PGA, meaning that you have all these operations that are taking place inside the server process, then that's going to mean that the server process is going to take longer to do the writing into the video log buffer, into the database buffer cache. So you want to set up a PGA size just about right, that you can get the server process to do more optimal writing into the database buffer, into the video log buffer. Again, this is how the PGA would have influences your the performance of your database. If it's too large, then more work is done by the PGA, which actually makes it more difficult for the server process to do the writing. And then what's going to happen is that if this part is slow, then everything else will be slow. So you want to avoid, you do not want to do that. So just set it to, as I've told you, just get the overall, get the value for the physical memory inside of your environment, and set it to 16% for the OLTP and 40% for OLAP or data warehousing. And again, the parameter that you use to set this up is the PGA aggregate target. And then in terms of, this is actually, okay, in terms of the stats pack. So basically what the stats pack does is it actually is used to gather system statistics. You can use that to create a report. You can use a stat page to create a report. So basically, I'm actually show you guys how to, some demonstration on how to set up your stat pack utility, and how to use it, to gather statistics for your environment. I have these two windows open. Actually, I have. Oh man, I have here I have an Oracle 11G, and here I have an Oracle 12C. So what I'll first do is, actually, you know what? Before I do that, if you look at the different directories that I have up here, so again, this is the most the one directory that I'll be using a lot today is actually this directory, the Oklahoma RDBMS admin directory. This is where you have a lot of the SQL file that you use for for performance tuning. So I'm gonna go into that directory right now. This is this directory for 11 GR2. I'm gonna copy this. Let me do this. Set Oracle underscore SID to. I've named my database funnel, so I'm gonna SQL plus sysdbs. There you go. Okay, so what I'll do now is I'm actually going to issue. I'm gonna execute this. I'm gonna execute the cat db send SQL, and I'm also gonna execute these scripts sequentially, because these two actually, because these two are actually this is how you set up the stats pack utility. And then, so again, I've already run the scripts in my environment, so it's probably gonna give me some some message about that these information inside of these packages already being installed, but that's fine. I just want to show you guys how to do it. So add, paste, and then the first one is cat db syn. Okay, so basically what it's telling me is that, again, so I already have this information inside the database, so that's fine. So I'm gonna go into my this one is named Andromeda, but I know I'm missing an A, so yeah, I definitely bungled on this one. And the reason why I'm doing both is this is a utility that you can use across the two Oracle versions, 11G and 12C. So I'm gonna run the same statement. I already have this directory also open. I'm gonna copy this, and then what I'm gonna is again cat db syn. Okay, so again, this is basically all. This is again, all these objects are already inside the Oracle database. So the next command I'm going to use is dbms bool.sql. So let me do this. Add dbms bool. Okay. So again, what this is doing is, you're just creating packages. Again, I'm gonna go over what this is again. Okay, you know what? This is when you issue these two commands, you're getting the environment set up to actually ultimately use this to basically rely on this user to do the administering for the statistic utility. And then the user is going to be the perf stat, and then you have to go to some setup screens to assign a password and different table spaces for this user. And then let me dbms bool. Okay. And then the next statement I'm gonna run is sp create. Again, sp create. Okay, so here I'm just gonna set up passwords for perfstat. So I'm just gonna assign the password perfstat. That's fine. Password perfstat. Okay, default table space. Again, the information is gonna be reached to the CSR table space. So that's fine. Enter. Tab space, that's fine. enter. Okay, enter. Again. So basically, if you look at what it says, I'm just getting an error because I already have all this set up. So basically, you know, the user perf set is already already able to do the administration for the Snapback utility. So let me do this. I'm gonna minimize these two. And then, so in terms of the perf set, what exactly you be doing is you actually be taking snapshots of your database. So basically, the snapshot is, again, what you be doing is you be like, you have information on, you know, what the system looks like, and let's say you experience system failures during the day, and then you can actually refer to you can actually go into that snapshot that you took early on to get a sense of what the database looked like, and then you can actually bring the database back up to that, you know, to what it looked like before. So that's for purpose of a snapshot. You know, it's a good reference point, when you're installing your database. So actually, what I'm gonna do is I'm gonna log back into my see. Okay, there you go. SP Auto. So basically what I'm doing here is I'm just taking a snapshot of my local software, and if you look at this reading, right? So it's just telling you, okay, so again, if you look at the number of jobs, right? So I took a snapshot yesterday, so that was job number 1. So it's telling you right now that it's job number 2, and it's telling you what time the next snapshot is gonna occur. So it's gonna be at 8 a.m. What it looks like. Actually, you know what? Or 8 p.m. Yeah, it could be 8 p.m. today. So again, just make sure you look at the reading. It's gonna, and basically you'll be able to see like exactly what will be the next snapshot time for the Open database, and basically and how you would basically do the reading for your how you would read your the report is you would just again go to it's only inside the same directory, so you would type this in, report, and then basically you'll be able to look at what the snapshots are, the individual snapshots are. So basically, snap ID is the first one, snap level 0, the host, and database ID, instance ID. So and I know okay. And another thing is, if the first time you set this up, but you know what? The first time you set this up, basically what's gonna happen is that basically you have a it's gonna give you an error. It's gonna say the database ID is not the same as the instance ID, which is actually you're gonna think to yourself, okay, what's going on? This is the first time I'm doing the configuration, so why am I getting this error? But again, you have to what it's basically telling you is that this is your first time using StatsBack, and you just need to take a snapshot before you can actually do some of some other comparison for your statistics. So what I'll do now is basically it's going to start gathering. It's going to start gathering snapshots. And also one of the things that I'll mention is that so with snapshot you can basically you can gather statistics as many, you can gather as many statistics throughout the day as you want, or you can gather as little statistics as you like. But the thing is, it's actually recommended to have a lot of statistics throughout the day. The reason why is you want to have information on the database. Basically, when it's consistent throughout the day. So let's say, again, if you want to just do an entire, take the whole day worth of a snapshot. What would happen is that, let's say you experience a system failure, like let's say working 9 to 5. You come in, the snapshot will be taken because you created, it's a job. That's fine. But you're going to be able to leave like around 5 or 6. And then you experience system failure. What would happen? Basically, you would have to rely on the snapshot from earlier during the day, which is something you not want to do. You want to have the most you want to refer to the most consistent data for the database. So it's actually recommended to just take as many snapshots as possible. And just imagine that same scenario, and you have it's 5 or 6 and you're getting ready to leave, but you'll be taking snapshots regularly throughout the day, and you have a snapshot of, let's say, like around 4:15 or 4:30, and basically you will feel much better in terms of how to compare the two databases. Basically you'll be able to say, okay, for 4:30 to 55 is not so bad. So this is a very consistent state for my database. So again, this is basically how to perform. I'm going to take you guys now on to how to perform a snapshot. Again, basically you create a report by using the SQ report, SQL. Again, what generally happens is that the stats back actually takes gather statistics every hour. So as I've told you, every hour is fine, but again, that's a long time, and anything can happen. In between those hours, you can see some failure, or and again, what you really need is the database that's really consistent. And the only way to get that is if you follow what Oracle recommends, that I've told you. Yes, you can just perform a gather statistics every 5 minutes, and so basically you'll be able to compare the environments and kind of get a sense of what the database looked like before. So now I'm actually going to I'm gonna show you guys how to use how to do the statistic gathering with PerfStat. And again, this is an actual user. So what I'll first do is, what you want to do is you want to connect as PerfStat. And I think the password for this one is this. PerfStat. There you go. Okay, so what you want to do next is you want to issue this command: execute stats back that snap open paren I underscore snap underscore level equals again, I'm gonna cover what exactly what the things that I'm gonna show you guys right now. So, no, not that. Take that away. So, again, here when you get to this point, right? You have a number of snapshots that you can take. So, level 0 would be just a general performance statistics. Level 5 would be a general, along with SQL statements. Level 6 would be a general with SQL plans and their usage. Level 7 would be again general with segment level stats. And level 10 would be a general again with parent and child latches. Last time I took a snapshot was I just took a general performance snapshot. But this time I think I'm gonna do a SQL statement snapshot. So again, when you get to this point, just put in whichever type of snapshot you want to take, and then close it. Execute. But you know what? Do this. I don't know why it's doing this one now, but typically you just be able to issue this statement. Stat pack snap. Okay. What I'm gonna do is I'm gonna pause on that and I'm gonna pick it back up and I'm gonna show you guys. I'm gonna show you exactly where I stumbled in terms of executing that statement.